Assalamualaikum. My name is Ahmad Aziz Amri bin Muhammad Yusof. My matric number DE190096. I am from section 1. Now I would like to present about the assignment 1, Intelligent Control System. The project name is Recurable Material Classification using CNN. Okay, for the introduction for this project, insufficient landfill problem had increased the needs to decrease the waste and recycling them. One of the possible reasons to this lack of effort to categorize the waste into the design category, which are can and plastic bottle. For this project, I have conducted the designing of CNN model to train the data without outfit or underfitting. For every process, I have analyzed the performance to detect PET bottle and aluminum detection material classification. So for this project, there are three tasks, which is task 1, task 2, and task 3. The sample image are ready given by the instructor. In order to achieve the final output, this project was being conducted by using Google Colab. Google Colab is a platform that allow to write and execute arbitrary Python code through the browser and will suit to machine learning, data analysis, and education. Okay, for the methodology in this project, by using the Google Colab as platform to get the image processing, the method that was used is CNN or convolution neural network. It is a class of deep neural network. It is most applied to analyze individual image, and they are also known as shifting invariant of space variant network based on their share with uh, attracted and he translation invariant characteristic. Okay, for the task 1, without pre-training or pre-trainer. Okay, this is the coding for this project. Okay, now you can see the epoch. So this the result. Okay, for the figure 1, the result that was show is the training and validation accuracy for output graph. Okay, for this task parameter has been used for the stat per epoch. The value is 10, while for epoch the value that was used 15. Okay, it can be said the training accuracy is higher than the validation accuracy. Okay, for the figure 2, uh, the graph show the training and validation loss output. Okay, we can see from the graph that for the training loss and validation loss, um, we can see the epoch 10 validation loss is lower than training loss. It can be concluded that the training accuracy and loss is higher. Okay, for the task 2, okay, we can see the coding for this project for the assignment task 2. Okay, you can see okay the result for task 2 are using pre-trainer ResNet. Okay, the training and validation accuracy has achieved 90% accuracy, which almost 100%. Okay, the highest value for training and validation accuracy are 1, Why the lowest value for validation is lower than 0.98. Okay, as for the trainer, the lowest 0.86, which is the lowest value obtained. Okay, we can see for the figure 4. Okay, this is the paragraph for the training and validation loss. It can be said that the loss for training and validation are quite low, since almost all of them are zero. For the training, the highest value for loss are higher than 140, which is the higher from the graph. It can be concluded that if the training and validation are done by a pre-trainer model, which is next ResNet, the current. Okay, for the net method, I use injection v3. So this is the coding for the reception v3. Okay, you can see the result. Okay, for the result, based on the figure 5, the majority of the training data almost achieve 90% accuracy and validation, which is to obtain 1. Okay, the lowest training accuracy is 0.75. While for the evaluation, for the lowest below than 0.95 at 2. Okay, we can see the figure 6. This is the graph about the training and validation loss. The most of the value are 0. Which the loss is low. Okay, the highest for the training loss are below 500, as for the validation loss, most of it are 0. It decrease and increase at 2 after that it become optimal. It can be concluded that when training with the pre-trainer model, which is using exception v3, the accuracy is higher than compared in the task 1. That's all for me. Okay, this is the task 3. To find the method that able to solve the problem and throw in one paragraph, summarize how the method work. Okay, for the answer, the task 3 is RCNN, or region-based convolution neural network, are a class of algorithm for tackling object localization and recognition problem that are optimized for model performance. And the second one is YOLO, you only look once, is a second family of object identification system target for speed and real-time application. Here is the description about the region-based CNN and YOLO method. Okay, for the conclusion for this project, as a conclusion, I can say that the objective were certified with the success of CNN using different type of training method. The first objective aims to developing a CNN using multiply training model for the purpose of comparison between the trainers. The second objective is to observing the accuracy of each trained model using the plot graph of training loss and occurrence. That's all for me. Thank you.